Most enterprise leaders look at their organizational chart and see static blocks of labor. When a new automation tool arrives, the instinct is to swap the human out and drop the software in. The integration fails because artificial intelligence cannot navigate abstract ambiguities. It requires structured parameters. Achieving an AI-native operation requires a total teardown of how you conceptualize work. We can see this engineering reality mapped out in a 12-point framework. The first phase demands a strict cognitive shift before a single line of code is written. The second phase dictates rigorous problem selection and system architecture. The final phase governs secure, context-aware deployment. We are going to build a complete deployment pipeline that proves that system constraints, and not just raw capabilities, govern our operational success. Sustainable enterprise AI operates as a 3-layered architectural stack, built from the human layer upward. We start by returning to our primary obstacle, the monolithic job. In operational terms, every job is actually a sequence of discrete, interconnected tasks. Machine intelligence accelerates these individual, localized nodes, targeting specific actions rather than the sprawling abstraction of a full role. This requires a behavioral reflex. Being AI native means instinctively reaching for tools at a granular level. This introduces a strict cognitive boundary between localized action and global comprehension. Tactical thinking, the high-speed sorting of localized data, is a mechanical process that you can permanently outsource to machines. Understanding, however, requires strategic oversight and accountability for those actions. That remains entirely human. When we map this division of labor onto an operation, a clear hierarchy emerges. Outsourcing that top-level comprehension causes the system to lose its anchor, leading to immediate operational fracture. Dismantling the job into verifiable tasks is the psychological prerequisite. Without it, process engineering cannot begin. Once the human psychology is aligned, we can move to system methodology. Here, we hit an unbreakable law of engineering. You cannot automate what you cannot map. Theoretical steps transform into a rigid architectural blueprint with branching logic and failure states. Every map requires a singular validation point, a North Star metric, proving the architecture works. This number dictates the difference between meaningful optimization and mere operational noise. This leads to the most common error in enterprise deployment, applying intelligence to an inefficient step. Automating a broken process does not fix the process. It simply takes a localized failure and catastrophically scales it. To avoid this, we look to Rule 5. The system constraint is the single location where work actually compounds. Within any map, one bottleneck node dictates the throughput of the entire system. Automation applied outside this restriction generates excess inventory instead of actual value. Surgical targeting of this constraint is the only valid deployment method, instantly equalizing the workflow. Strict methodology demands the ruthless discipline of deploying resources solely at the exact point of restriction. Now we examine the internal mechanics of the deployed AI operating at that specific constraint. The industry focuses obsessively on the language model itself. Rule 10 shifts the priority, defining context as the governing force of the entire system. Architecturally, context is the protective wrapper engineered directly around the model. This layer contains the business rules, prompt boundaries, and historical state data anchoring the model to reality. A naked engine hallucinates. A context-wrapped engine synchronizes with your operational parameters. This brings us to the unforgiving security reality regarding data access. In this environment, the engineering law is absolute. Access equals use. Clever system prompting cannot override permissive access controls. If the pathway exists, the engine will eventually exploit it to generate an output. Strict architectural boundaries at the data layer are the only true safeguard when building the machine. Building the machine requires spending 10% of your time selecting a model and 90% engineering the secure, context-rich environment around it. We now have a fully integrated pipeline, running seamlessly left to right, accelerating our constraint and driving the North Star metric. This is the result of aligning the mindset, the method, and the machine. Operating these systems reveals a final engineering reality. You finish building, you don't finish owning. In this context, ownership means carrying permanent accountability for the localized decisions the machine makes. This requires an ongoing architectural feedback loop, not a static finish line. As the intelligence outputs work, the environment shifts, requiring the human operator to constantly update the context layer. Artificial intelligence functions as an amplifier for the rigorous human systems that house it. Technical execution is the easy part. The true test of a leader is the discipline to map the process, constrain the context, and own the results forever.